We often take it for granted that stars shine, atoms bond, and life flourishes. But what if these wonders only exist because the universe is unbelievably fine-tuned? Welcome back to Infinity Beyond. In this segment, we explore one of the most provocative ideas in modern science and philosophy: the fine-tuning of the universe. The idea that certain physical constants, the deep numbers that govern the structure of reality, are set so precisely that even the tiniest change would result in a lifeless cosmos. Let's begin with the forces of nature. There are four fundamental forces in the universe: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Each plays a unique and essential role in shaping the cosmos. One of the key ratios that scientists study is the relative strength of electromagnetism to gravity. If electromagnetism were significantly weaker, stars might never ignite, or they would be unstable. If gravity were much stronger, stars would collapse too quickly, live short lives, or become black holes before planets could form. But in our universe, the balance is just right. This delicate equilibrium allows stars to burn steadily for billions of years, providing the consistent energy necessary for life on orbiting planets like Earth. Now consider particle masses. The electron is about 1/1836 the mass of the proton. This tiny ratio determines the size of atoms, the way electrons orbit nuclei, and the very nature of chemical bonds. If the electron were significantly heavier, atoms would shrink, and chemical reactions might not behave the same way. Molecular complexity, the kind necessary for life, could be impossible. If electrons were too light, they might not stay bound to nuclei at all, meaning no atoms could form in the first place. But somehow, the mass ratio of electrons to protons is precisely what it needs to be to allow chemistry, biology, and eventually consciousness. And it doesn't stop there. There's the strong nuclear force, the force that holds the nuclei of atoms together. If it were slightly stronger, protons and neutrons would bind too tightly, and hydrogen, the simplest element, might never have formed. No hydrogen, no water, no stars. If the strong force were slightly weaker, nuclei wouldn't hold together at all. No helium, no heavier elements, no life. And how about the mass difference between protons and neutrons? This difference is subtle, just about 0.14%, but critical. If neutrons were just a bit heavier, protons could decay into neutrons, and the universe might lack stable hydrogen. If they were closer in mass, neutrons wouldn't decay properly, affecting nuclear stability and element formation. Even the cosmological constant, the value associated with the energy of empty space, often linked to dark energy, is fine-tuned. A tiny increase, and the universe would expand so rapidly that galaxies couldn't form. A tiny decrease, and gravity would cause the universe to collapse back into itself. The odds of all these values being perfectly aligned are mind-blowing. Many physicists compare it to balancing a pencil on its tip during an earthquake, or randomly dialing every number in a safe combination correctly on the first try. And yet, here we are. This brings us to the anthropic principle, the idea that we observe the universe to be life-permitting simply because we're here to observe it. If it weren't, we wouldn't be around to notice. Some see this as a satisfying answer, while others find it circular or incomplete. There are several ways scientists try to grapple with this fine-tuning mystery. Chance? Maybe the constants just happen to be right. A cosmic lottery with impossible odds, but we won. Necessity? Perhaps there's an underlying theory, a theory of everything, that demands these constants. They had to be this way, and life was just a consequence. Design? A controversial and philosophical notion that suggests intentional calibration, perhaps by a higher intelligence or unknown creative force. Multiverse, one of the most intriguing scientific theories. If there are many universes, each with different constants and laws, then it's not surprising that one of them, ours, would support life. We just happen to live in the one that works. The multiverse theory is elegant in its probability, but frustrating in its testability. How do we confirm other universes exist when we can't observe beyond our cosmic horizon? Still, it offers an intriguing way to explain what would otherwise seem like an impossibly lucky accident. As we marvel at stars, ponder atoms, or gaze into telescopes, it's worth remembering that the very structure of reality appears tuned for existence, for stability, for complexity, for life. Does that mean there's meaning built into the cosmos? Or is meaning something we impose upon the stars? Either way, we're part of something incredibly rare or incredibly vast. The universe didn't have to be this way, and yet it is. And perhaps that's the most extraordinary fact of all.